In the last video, we have understood about the different features of OPCUA information model. And in this video, we are going to see how we can able to create an information model of a real-world system using the node.set file. So starting with step one, we need to document the requirements by analyzing the real asset. For example, in the case of a coffee machine project, this will contain the water tank, pump, heater, recipes, etc. And on the step two, we need to design the information model. That means we need to create the UML diagram using the tools such as Pro.io or Visio. And this will be giving a good structure of the information model which we are going to design. So in the step three, we are going to create a node.set file. So before going into the node.set file, we need to understand that we can able to create the information model in different ways. The first one is we can able to create the information model by using the APIs of the OPCUA server library. But let's consider if we have 100 plus nodes are available in our project, then we need to manually program each and every node. So that is a tedious task. So the OPCUA come with another feature which is called a node.set file. So this is a customized version of an XML file which follow the OPCUA standard. And this node.set file can be generated by tools such as UaModeler, and we can able to design the information model inside the UaModeler tool, and we can able to export the output file as a node.set file. So the interesting thing is this node.set file will be supported by the OPCUA server, so that you can able to load this node.set file directly to the server during the runtime. So you can able to avoid the manual programming part here. So apart from this one, we can able to generate the source code for this library from the node.set file as well. So some of the OPCUA server libraries are supporting the compiler, node.set compiler, which will convert the node.set file to the source code of that library. So this will be mostly applicable to the embedded devices because the main constraint here is when you are loading the node.set file, it will consume more memory. So in order to avoid that one, we will be directly generating the source code for the information model. But I think in most of the use case scenarios, the loading the node.set file directly will be enough. So the next step is the implementing the business logic. In case of a coffee machine project, we can make methods like make coffee, fill tank, etc. And we need to implement the internal logic of these methods inside the server using the respective API of the library. And next is we will be running the server and connecting the server to the client, and we will be performing the testing part as well. For the demo part, we are going to design an information model which I have created in the Pro.io. So this is the information model which we are going to design, and it consists of a test folder and a test object and a couple of variables. So this is the UaModeler, and here I have already created a test model project, and here you can see on the right hand side window there are two namespaces. One is the standard namespace from the OPCUA Foundation, and the second one is the new namespace created for the user. So we will be using the second new namespace to create our nodes. So first I'm going to create a test folder under the objects. Now we can see that we have created a test folder. And next I'm going to create a test object. Its type is base object type itself. And under the object, I'm going to create a couple of variables. and its type definition is I'm using the base data variable type itself. Just changing the data type to int16 for the second variable. Now we can see that we have the two variables. One of the things you have to notice here is the references are automatically set by the UaModeler itself. We can able to change the references by ourselves by coming here. And one more thing which I need to showcase with the UaModeler is while we are creating the information model tree structure, you can able to visualize the diagram in another window. So here you can see that the test folder and its relation with the test object, and yeah, it's showing the parent child nodes and yeah, its connections as well. So the next step is I'm going to log this model so it will avoid any accidental changes, and I'm going to export this XML. And in the log window, you can see that we have exported this nodeset file. Now I have copied the nodeset file from the UaModeler project folder to my test server folder. And this is a test OPC UA server based on free OPC UA library. And so this will accept the nodeset file as an argument. So right now I'm going to run the server. And here we can see that the nodeset is imported successfully. I'm going to connect with the UAExpert client. And here you can see the test folder and objects which we have created from the UaModeler. So you can find this project by the link provided in the description of this video.